So what I could do is I could do this. Aha, things have moved on a little bit now, haven't they? So I've got two things there. I've got this, which is going to do this, and I've got this, which is going to do this, but they're in parallel. Now your maths has to up a little bit to be able to work out what's going to go on here, and I'm not going to do it in this session, I don't think. But you've got two different kinds of behaviour. So this one wants to go short circuit when the frequency's high. This one wants to go open circuit when the frequency's high. And yet they're both on the same connections. So logic should probably tell you that it's going to have a bit of behaviour of both. And a bit of logic should probably tell you that the graph is probably going to look something like that. So it's not going to pass high frequency, it's not going to pass low frequency, but it's going to do something interesting in the middle. That's what that tells me, because it's going to be a combination of the two trends that we've seen so far, right? Now I want you to simulate that, but before you do, just let me run you through why that is so important. Because if I've got this, and you may have seen this before, it's the symbol for the Essex Amateur Radio Society. That's a radio. That's a radio. All I need to do to make that select stations for me is to make that a variable capacitor. And I can tune radio stations in. Isn't that remarkable? Why is that a radio? We said earlier, RF is incredibly complicated to understand, and yet all I've done is a couple of components, and suddenly you've got a radio. How can this be? That's really because of that, which you're just about to plot for me. And once you do that plot, then you're going to see why that forms a radio. In its simplest form, it would be this. That would be a set of headphones or something like that. And that was used all the way through the Second World War for prisoners of war and so on to be able to communicate back to the, or for the UK to be able to communicate to them. But look, it's an inductor and a capacitor in parallel. Okay, we put a resistor in there because otherwise the circuit doesn't simulate very well. Because if the resistor's not there, the input's the same as the output. Do you see where I'm coming from? So, to start off with, let's say that's 100. Let's say that's 1 microfarad. And let's say that's 1 millihenry. Okay, simulate away. See what happens. So you know how to draw now and